Suppose we have an equilateral triangle ABC, and of course it will have a circumcircle that is circumscribing it. Now we take a minor arc created by any two vertex of the triangle, and on that arc I would take a point, let's say P, point P on that arc. Now I am connecting this P with a third vertex of the triangle. Would this line have some special or interesting properties? Let's understand this using a problem that came in Singapore Math Olympiad senior section. Hello students, I'm Deepan. I'm a faculty here in Cheenta. Let's get into the problem. So this is the triangle ABC is an equilateral triangle, and this circle is the circumcircle of the triangle. Now, on the minor arc of BC, which starts from here until here, all on this arc, I take a point P. This is my point P. On this P, and I take the point P. Then I connect P with A, where obviously it will intersect BC at point D. Now the conditions are BP is 5 and PC is 20. I have to find what is the length of AD. That is the question. So let's try to understand what can be the strategies to solve these kind of questions. Well, they're barely given some informations. Just 3 informations are given. Number 1, ABC is an equilateral triangle. So let's try to gather all informations out of that. As it is an equilateral triangle, so all these angles I'm marking right now will be 60 degrees. Well enough. And I can understand very clearly that A, B, P, C is a cyclic quadrilateral. So that means this angle would be 120 degrees. As it is 60, opposite angles are supplementary. Now, as I already told about the angles, so there is a theorem called inscribed angles. What does it say? If I take a particular arc, for example, let's take here the arc AC. On this arc AC, how many angles I subtend to the circle? For example, here ABC, APC, both of them are on this arc and they are creating an angle. So that means this angle and this angle must be equal. That implies this is 60 degree. I knew that. This has to be 60. Similar argument on the arc AB. On arc AB, ACB and APB both are inscribed angles, so they have to be equal. They are 60. So we can conclude one thing, that in triangle BPC, PD is an angle bisector. We can conclude this one. Okay, these are the informations we already get. Now, let's see what else we can do, because no, I haven't get any information about AD yet. So I need to do something else as well. So what can I do here? Obviously, one thing is great actually about this question, that is I'm getting a lot of 60 degree angles. That is definitely gonna help me. And further, I'm just looking about this angle, because they are vertically opposite angles, they must be equal. Well enough. That gives me that triangle ADC and triangle BDP must be similar by AA criterion. If two angles of triangles are congruent, then triangles must be similar. I'm getting them similar. So the ratio of the corresponding sides of similar triangles must be equal. Now I can involve the AD. I'm getting some idea regarding AD. What can I have? Let's say AD upon, here it will be BD, maybe equal to, let's involve AC upon AC upon BP. I can have this. And this also should be equal to, let's say, CD to PD. Okay. This is one of the information. Maybe we can use any one of them to equate with AD upon BD and get the thing. But for that, we need to find AC and BP and BD as well. Let's try to use this too. Let's see what can we get. One thing is directly pushing me to use cosine rule in triangle BPC. Why? Because wherever we get two sides and the angle between them, that's a direct indication that I am allowed to use the cosine rule there. So what am I getting there? So BC should be equal to square root of BP square plus CP square minus twice of BP times CP times cos, here it will be 120 degrees. This is what we are getting. So let's get the value of it. BP is 5, so it will be 25 plus CP is 20, so it will be 400 minus BP is 5, this is 20, 100, 200. Cos 120. We can use one formula here, that is cos of 90 degree plus theta is sin theta. That means cos of 120 will be sin 30, which is, sorry, my bad. Cos of 9 plus 3 is negative sin theta. So it will be positive half. So what will I get here is 400, 125, that is square root of 525. Okay, 525. If I factorize this, let's go with the 25. 25 twos are 50, 25 ones, that means this is gonna be 5 under the root 21 units. Okay, we get the BC. One interesting thing about BC is whenever we are getting BC, we are getting AC as well, because ABC is an equilateral triangle. Very good. So we are done about AC. Now we need to do something regarding BP and BD. BP and BD. So one more thing that I observed earlier, that is this angle bisector. Maybe we can get something using angle bisector theorem. So what is angle bisector theorem? I'm just going to give you a very short introduction of that. Let's assume this is a triangle. Let's name the triangle as XYZ. And I have this line which is bisecting the angle X equally. If I have the information, this is A, this is B, and this is, let's say, P, this is Q. we can have A upon P equals B upon Q, or A upon B equals P upon Q. We will use this theorem here. How can we use? So if I just write down the same thing here about BPC, so it will be our P. This will be, let's say, our B. And this will be definitely our C. So BP was 5. CP was 20. Okay. Now let's see what can we figure out. So what are we getting here? BP, let's say. BP upon CP equals, this is the point D, BD by CD. This is what we are getting. Now, BP by CP is 1 upon 4. That is giving us CD is 4 times of BD. That is something very interesting. Why? Because I got the entire BC. BC was 5 root 21. And now I'm getting CD is 4 times BD. That means CD is to BC. BD is 4 to 1. That means, what do I need? I need the BP and BD. BP I knew, BD I need the BD. BD would be 1/4 of BC. That is root 21. Okay, now I got everything about the first equality. So let me write that as well. AD upon BD equals AC upon BP. So AD would be, AC was 5 root 21 divided by BP was 5 times the BD, which is only this. So I'm getting 21. There it is. So AD would be 21. Now I guess it is clear how can we figure this out with just these kind of informations. But I generally say this after the videos or after the solutions, that it's never gonna be the unique solution. There will exist some other solutions, and there do exist. Here's a challenge for you guys. Try to solve this using Ptolemy's theorem. And let me know, are you getting something special about the point P? Are they gonna be like BP plus CP? Are they gonna be constant? Or if yes, then what can be the proof of that? Try to use Ptolemy and try to prove that. In that way, it's gonna be another solution. And if you get that, do send me the solution and we can have a video together. So see you in the next video, and till then, continue to do good mathematics. Bye.